Hello students, welcome to my YouTube channel Concept Clear with a new video of learning and excitement. I'm hoping that these videos will help you to improve your knowledge and skills. So today without any delay, let's go to the topics what I'm going to discuss. So today I'm going to discuss about full adder circuits. Basically we'll see how the full adder circuits will operate, what are the different inputs and outputs will be there. After that, I will write the full adder circuits in Verilog in Xilinx Vivado tools. Then also we'll write a test bench for that code, and with the help of test bench we'll verify whether the full adder output is coming correctly according to the logic or not. So let's go to the topic of full adder. First we'll see how it will operate. If you'll see, this is with respect to a full adder, it is representing a full adder. So here these are the input bits A, B, C in. We have three inputs A, B and C in. These are the three inputs and two output will be there. One is sum and another one is output carry. So this is the block diagram. If we'll go for circuit diagram of this full adder, what we'll see here, we'll see that this A, B, C is as inputs. AB is passed through an XOR gate. This is one XOR gate. Then its output is given to another XOR gate, where another input will be C in. So this is the final sum, and sum expression will be A XOR B XOR C or C in. Then coming to the carry out we generally know the carry out expression will be AB plus BC plus AC, or we can another way we can see here, you can see this is the one input is given to an AND gate and this input is coming from C in. So here the output will get A XOR B into C in. Then here you are seeing A is coming and B is coming, given input to the AND gate. So here output you will get A into B. Both are given to a OR gate. So here the output will be AB plus A XOR B into C in. Okay. So now with respect to this logic circuits, we have to design or we have to write the Verilog code, and after that we have to verify by the help of a truth table. We'll have A, B, C as inputs, then these are the outputs, A XOR B XOR C in, and another is AB plus A XOR B into C in. Okay. So now we'll write the code first in gate level modeling or structural modeling. For gate level modeling, you should have idea about what are the different logic gates are connected and what is the primary input, primary output, and the intermediate input and output. So in this is the logic circuits. With respect to these circuits, we have to write the Verilog code. So let me first tell you what are the primary input and what is the primary output of this one. So I am deleting all. So now here we can see that A, B, C in are there. These are the two inputs. These are the A, B, C in are inputs. These are directly given by the user. So it is known as primary input. And what output is there? Sum and carry as the output. So these are the primary output. This is known as primary output. This is primary input. In between, in some intermediate output and input will be there. For example, here A, B are given to this XOR gate, and here we are getting one output. That output let us write W1. It is an intermediate output which will also act as an intermediate input for this XOR gate. Again, this is an AND gate is there. Here two inputs is, one is C in, another is A XOR B. Okay, so here we are getting one output, that is also this A XOR B is nothing but W1. Here also we are getting one output, that will be also intermediate output, that can be given as W2. Again, that W2 is output for this AND gate and input for the this OR gate. Similarly, this AND gate two inputs are there, A and B. which are primary inputs, it has an output that let us consider W3. So here we have three intermediate variables. One is W1, W2 and W3. These three variables are neither a primary input nor a primary output. These are the intermediate outputs or inputs. Now whenever we have to write the code in structural or gate level modeling, these W1, W2 and W3 should be declared as a where, and it should not be declared in the module input and output port. It should be declared in that Verilog code, in that area where we are writing the Verilog code. Okay, so now without any delay, let's go to the Vivado tools. There we will write the code. So this is the code. Already I have written this module full adder S, which is a module name with respect to the full adder circuits, and this S represents that it is a structural level or gate level modeling. Here I have declared the input variable as input A, B, C in, output as sum, carry out. So if you'll see here, this is A, B, C in three inputs, and output is sum and carry out. With respect to this circuit, you can see A, B, C in, sum and carry out. Next, intermediate output is there, W1, W2, W3 and W4. So for W4 is not needed because we want only three variables, W1, W2, W3. Now what are these? Already I have discussed. You can see that this W1 is the output of A XOR B, which is the intermediate output. Again, W2 is the output of this AND gate. W3 is the output of this AND gate. These are three intermediate output or input that will be declared as OR data type. Okay, this is OR W1, W2, W3. Now for gate level modeling, we know that we have to write the logic gates as I have written XOR. Then we have to give a name of the gate that I have given G1. Then first we have to write the output name followed by input. So this is W1 is the output, A and B as the input. Again, similarly another XOR gate is there. So here we will have sum is the output, W1 and Cin is the input. Now we'll see that one here. So here W1 is the output of this XOR gate, A and B are the input. For this XOR gate, W1 and Cin as the input, sum is the output. Okay. So this two XOR gate is over. Next, coming to the AND gate, here the output is W2 and the input is A and B. And another one, output is W3, input is W1 and Cin. Or according to the circuit diagram I have taken, this is W2. So just I will make a change here. I can write this is W3 and this is W2. So according to my circuits, I just changed. So this is W2 where this AND gate output, and it has two input. One is Cin, another is W1. So Cin W1, that output is W2. For AND gate where the input is A and B, for that output is W3. So you can see that W3 is the output, input is A and B. Okay. Now this is another OR gate. For this OR gate, W2, W3 is input, output is carry out. So finally this carry out is the output, W2, W3 is the input. This is the code for full adder, which is gate level modeling. Now if I'll save this one, already I have done this one. So if I'll save here, so coming to this design source, you will say that there is no syntax error. This full adder underscore S is showing, and this is also showing that top module. This symbol is representing that this is a top module. Okay. What is the significance of top module? Because whenever you have to do the simulate, if like in this case many design sources are there, whichever is in top module, that will run or that will be simulated with respect to the input or simulation source or test bench. So now we can see that one. So this is your Verilog code of full adder in gate level or structural modeling. Now we have to write the test bench for it. Generally, test bench will be similar for all types of circuits. Okay. Now in this case, how many inputs are there? A, B, C in. So three inputs are there. These three inputs will be initialized in the test bench. Let's go to the test bench. So this is the test bench I have already written. Let us understand this test bench. So for test bench, I have given full adder underscore TB. In test bench module, there will be no input port and output port. That is why in this open and close bracket, nothing is written. It is only for using to initialize the input. So there will be no input and output port. Then how many input variables we have? Three input variables. So that three input variables should be declared as register. As I have declared A underscore T, B underscore T, C underscore T. This is with respect to the input variables. Then output variables must be declared as OR data type. So here sum underscore T, comma carry underscore T is declared as output variables. Okay. So once we have declared the input and output variables, then we have to do the instantiation. We have to call the module. So then what is the module name? You can go to the module and see full adder underscore s. So that I have written here, full adder underscore s. Remember that whenever you are instantiating, the module name should be correct. That means if you have written in capital or small letter, that should be there. If any deviation will be there, then that module instantiation will not occur. You will not able to execute that module or that design source. Then after that, we have to pass this input variable to our design source, that is dot a in bracket a underscore t. This first a is representing this variable of design source. A underscore t is representing the variable in the simulation source or test bench. Okay. Then dot b underscore t, dot c in bracket c underscore t, dot sum underscore t, dot carry underscore t. So this carry out, sum, scene, b, a, these are the input and output variables that is declared in the design source. So once the instantiation is over, then we have to initialize the input. What is the inputs here? A underscore t, b underscore t, and c underscore t. So now every time for initialization we have to write initial. Since multi statements are there, we have to write the code in between begin and end. After initial, if a single line statement is there, then there is no need of writing begin and end. If multiple statements are there, then you have to write in between begin block and end block. In between begin and end, you have to write. So what do I have to do here? Three variables are there, a underscore t, b underscore t, c underscore t. So since three variables is there will be 2 to the power 3, that is 8 different combinations. So that combination I have to write here with some delay. If you are not giving any delay, then there is a overlapping of inputs, like 0 0 0 will overlap with 0 0 1. So the simulator will not understand which one it has to take. So there will be errors. So we have to give some delay, like I have given this is 0 0 0. After 10 nanosecond delay, I have given 0 0 1. Again after another 10 nanosecond delay, I have given 0 1 0. Like that 0 1 1, 1 0 0, 1 0 1, 1 1 0, 1 1 1. So with this all combination of input is over. Next we have to give the finish or stop. Why we are giving this one? If you are not giving, then maybe the simulation will go for some more times, so that your graph will not be visible. You will not clearly understand the graph. If you are giving this many combination and after another 10 nanoseconds you are finishing, then clearly you will see the graph and you will understand the graph. Okay, then begin will be end here and module will be end module here. So then you have to save. Already I have saved. So if not saved, for example, I just change here module, then we have to save here, or you can go to file and save. So I'll click save here. After saving this test bench, what you have to verify, you have to go to the source. In the source you are getting the simulation source full a fa underscore tb. Under that this fa underscore s should be there. If for example this capital S, I will make small s. See what will happen. I will save this. Now here it is giving a question mark, then dut full fa underscore s, and again you will see that fa underscore s is here. Okay, so this question mark is showing that this design source is not available. There is some error. So if again I will write capital S and I will save it, then you will see that this full fa underscore s will come under this fa underscore tb, and this will be deleted. So I'll save it. See here, this fa underscore s which was here, now coming here, this is coming under this fa underscore tb. If this is coming, then only you can confirm that whatever test bench you are writing, that is passed to that design source. Understood? So now again you have to check whether that test bench is top module or not. Since this symbol, this two blue one green symbol is showing here, this represents that it is a top module. For example, this is not top module, then how it will be? Let us make this is top module. Now this logic gates underscore tb is top module. So what I have to do, I have to select this one, right click, set as top. So now this test bench is top module with respect to this design source. So next we will go for the simulation. I'll click on run simulation. It will take some time to generate the waveform. If no errors are there, then it will generate the waveform. So there is no errors, so it is executed and we got the waveform here. So I will enlarge the waveform. Then I have to click on zoom and fit. Okay. So now we can verify this one. For example, whatever signal you are seeing here, it is representing with respect to cursor. The cursor is present here. Now I am taking the cursor here. So what is my input? 0 0 0. Output is 0 0. Again I will take my cursor here. After 10 nanoseconds I am changing the input 0 0 1. So sum is 1, carry is 0. Again I will take this cursor for the next input combination, which is 0 1 0. 0 1 0, same output will be 1, and that is sum output will be 1, carry output will be 0. Again next combination is 0 1 1. So in this case sum will be 0, carry will be 1, because 1 plus 1 is 1 0, 1 0 plus 0 is 1 0, 0 is sum, carry is 1. Similarly for the next combination 1 0 0, sum is 1, carry is 0. Similarly if you are going for the last, which is 1 1 1 case, what we are getting? Sum is 1, carry is 1. So by this analysis we understood that according to the logic the waveform is coming correct. Okay. Now further, if you want to see what is the circuits design for this, like I have taken this one, this is the circuits. Now I want to see whether this circuits with respect to the code design or not. To see that we can go to here, elaborated design, then we'll go to the schematic. So if you click on schematic, then the schematic will be generated. You can see that, you can verify this is the same circuits as we have seen here, these circuits, and the circuits is designed here, the schematic is almost same. Only the position, like exergate may be here, some position will be different, but this is the same circuit whatever we have seen or whatever I have explained, same is designed here. Okay, so for every Verilog code you can create the schematic and you can verify the circuits, whatever the circuits you have and whatever the circuits is created because of your Verilog code is correct or not. Okay, so thank you guys, hoping that this should be useful for you. and you'll get benefit from it. Thank you.